How's it going, guys? Today we're going to be reviewing another interview question. Today we're going to go over a problem called spiral matrix, and this is a question that's currently being asked by Amazon right now.
Lots of niggas sounding like me talk. Lots of niggas talking like me talk. Lots of niggas sounding like me talk.
Okay, guys, so today our problem is called spiral matrix. Again, this is one of the most frequently asked questions at Amazon right now. And the problem description says, given a matrix of m by n elements, m rows and n columns, return all elements of the matrix in spiral order. So the problem description is pretty simple. It's probably pretty self-explanatory, but in case it doesn't make sense, let's just walk through these examples here. So if we were given this matrix here in example 1, we'd return a list of numbers that contains the elements in the matrix in the order 1, 2, 3, 6, 9, 8, 7, 4, 5. And the reason for that is because we're going to traverse the matrix in a spiral order. And what I mean by that is we're going to first visit 1, then go to 2, then go to 3. And then we're going to go down to 6, down to 9, over to 8, over to 7, up to 4, and over to 5. So that would be a spiral traversal of the matrix, and that's the reason why the numbers that we'd return would be in this order. Again, just to walk through the second example now, we're going to do the exact same thing, right? We're just traversing the matrix in a spiral order, and that would yield this result here. And again, that's because we're going to go to 1, to 2, 3, 4, down to 8, down to 12, over to 11, 10, 9, up to 5, over to 6, over to 7. And then we'd be done. So this problem, I think, is particularly annoying just because of the code that you have to write, but I also don't think it's that hard to conceptualize. I think it's a great problem in the sense that it doesn't take you too long to actually understand, but I do think the code could be a little bit tricky. So what we really need to pay attention to are the bounds of our current matrix that we're traversing, right? So first, we're going to just traverse along the top row, and then we're going to go down and then back towards the beginning of the matrix and then up. And we basically need to make sure that we're shrinking our bounds every single time that we traverse the matrix, or at least the outer part of the matrix, before we actually start collapsing towards the middle. And so once we actually set those bounds, the problem isn't too hard, but it's still a bit finicky. So traversing the matrix shouldn't be too hard. We just need to make sure that we have those bounds. So I think if we have a top bound, a bottom bound, a left bound, and a right bound, it shouldn't be too hard. So the first thing I want to do is just to declare and initialize a return value. So it says that we want to return a list of integers. And again, that list will contain the matrix in a spiral order. So we'll say list integer, and I'm just going to call this nums equals new array list. And then we're just going to have a sanity check, right? Make sure that if we have a null matrix or the matrix's length is 0, we just want to return nums, right? Which will initially just be an empty array. And if we don't have a matrix, we have no numbers to add to that list. So we'll say if matrix equals null or matrix.length is 0, let's just return our nums. Great, so now if we get to this point, we need to traverse some sort of matrix. Again, it's n by n, so we don't really know too much about what the matrix will look like other than that, but we need to have those bounds that we talked about. So initially, the top row of our matrix is going to be 0, right? And as we traverse the top row, we'll move that down slowly, again, shrinking our matrix. So we'll have a top, we'll have a bottom that will be matrix.length minus 1 to begin with, and that's because we want to include all the numbers on the last row of the matrix before we slowly move those constraints, right, towards each other. And then we also want to have a left that will start at 0 to make sure we include the leftmost column in our matrix to start. And then int right equals matrix of 0.length minus 1 to make sure we include the rightmost column of the matrix to start. Now the other thing that I'm just going to do is a really simple check to know if we have all the numbers is simply if our list here, right, if nums, if its size is greater than, or really if it's equal to matrix.length times matrix of 0.length, then we've found all the numbers. So I'm just going to have a variable to know when we've reached that limit, and we can just simply return them basically. Or make sure we're not adding any additional elements that we don't need or that, you know, would then be a duplicate effectively. So I'm going to say int size equals matrix.length times matrix of 0.length. And that will basically tell us when we've gotten all the numbers that we need. So now I could just go through the matrix while that size hasn't been met, right? So while nums.size is less than the size of all the elements together, we need to continuously add those elements in a spiral order. And so now what we want to first do is just traverse along that top column, right? So in our example, we want to pick up 1, 2, and 3. So let's do that first. So first we could say for int I equals, and it's going to start at our left, right? Our leftmost column that we have currently. Well, I is less than, or I really should say less than or equal to right, I plus plus. And what we're basically going to add is nums.add, right? So we want to add all these numbers in that top row. And so this would basically be grid, or I should say, sorry, matrix of whatever top row that we're on and I, right? So that's going to move us through the column while still staying on the correct row. Great. And so after that, right, now we've gotten to this 3. And once we get to this 3, we need to traverse downward in our matrix, but we also want to make sure that we're not going to double count this 3 or add this 3 twice. So before we start processing this current column, right, we need to make sure that we say top plus plus. Also, something I forgot is we want to add this check in here, right? So if nums.size is less than size, then we can add those numbers. So now we basically want to traverse our top column all the way to our bottom column, right? So we really want to say something like for int I equals top, well, I is less than or equal to the bottom row that we should go to, and the size of our nums is less than the size, I plus plus. And now what we want to add, right? So we want to say nums.add matrix of top and right, right? So that will make sure that we stay in that rightmost column over here, and we basically are going down all of those rows for that right column. So now we've just done the traversal here, right? So you've gotten a 6, we've gotten a 9, and now similarly, we want to make sure we don't add that 9 again. So we definitely want to make sure that we scoot our right pointer over 1. So now we could say right minus minus. Awesome. So now we want to do this traversal back towards the beginning of our matrix, right? So we want to pick up this 8 and this 7. So to do that, we want to now write another loop. So for int I equals our right, well, I is greater than or equal to our left, and nums.size is less than our size, I plus plus, or sorry, I minus minus. And now we want to say nums.add matrix of, we're going to be on the bottom row, right? So bottom, and that's going to stay constant. And then we want to say I here. Great. So now once we finish that traversal back towards the beginning of our matrix, we want to make sure that we move our bottom up so that we don't double count before we go up our leftmost column. So we'll say bottom plus plus. Bottom minus minus, sorry. So now we just want to pick up that leftmost column before we start traversing the matrix all over again, right? That'll now be condensed. So the last column we have to pick up goes like this, for int I equals our bottom. Well, I is greater than or equal to our top, and nums.size is less than size, I minus minus. And now what we want to pick up is nums.add, right? Matrix of I, because the column is going to be changing because we're going upwards. And then this is going to be whatever our left pointer is at. So now once this loop ends, we basically finished that loop around our matrix, right? So this will be the first loop here. The second loop will be down this column, which will be the second loop here. The third loop will be going back towards the beginning of the matrix. And then that last loop that we just wrote will be going back up the leftmost column. So before we actually try traversing everything again, but squish it, right, make it smaller, we need to say left plus plus to make sure that we start on the next time we get back to that column, we need to make sure that we've moved in one column so we don't get new values, or sorry, duplicate values. So now when this entire loop has finished, all we should have to do is return our nums, hopefully. So now to talk about our runtime and our space complexity. Our space complexity is clearly going to be O of n, right, where n is the number of elements in our entire matrix, because we're returning all those elements just in a specific order. And then again, in our runtime, we're going to have to do the same sort of thing. We have to traverse our entire matrix. So we could also say that the runtime for our solution here is O of n, where n is the number of elements in our matrix. So now let's run this code. Let's make sure that it works. Okay, so I accidentally wrote top here and I meant to write I, right? Because that's going to make us go down that column that we need to traverse. And we don't want to hold it steady at that index, but we want to move it down each row every time. So let's run this again. Let's make sure that works. Awesome, and it does. So guys, that's how to solve spiral matrix in Java. Again, this is a question that's being asked by Amazon. If you guys enjoyed this video and found it helpful, do me a favor and leave the video a like and subscribe to the channel for more. And I'll see you guys in the next one.
Woke up to niggas talking like me talk. Woke up to niggas sounding like me talk. I woke up to niggas sounding like me. I woke up to niggas sounding like me. Woke up to niggas talking like me.